All right. Are you ready? Yep.
Yes.
Okay. So hello, everybody. We are going to start this video. It's going to be, I don't know, 45 minutes or something. And so this is going to be a video that we are going to use for us, first of all, to be able to reproduce this in the future. And probably this is going to be reused by someone else who wants to follow the steps that we are going to share today. So with me today, I have Michelle and Goktu, two of my top students for the last courses that I delivered at IE. And so they have been very kind, and basically they have helped a lot to make the course environment a reality in the new Apple computers with the new processor. Okay, so thank you very much for that, first of all. And I'm going to introduce you very quickly, and then obviously it would be nice that you could add something else, because that's going to be much better. So we'll start with Michelle, if you don't mind, Goktu. Michelle is one of my best students for the last courses, and actually she had to put out with me in two courses, the Spark course and the stream processing and real-time analytics. So she suffered a little bit all my explanations and all those things. And she has a bachelor in economics, and she's specialized in econometrics. So I don't have any idea about that. So it would be nice if you could introduce or elaborate that a little bit more.
Yeah, so as Ravu said, I studied economics in Germany, and I developed kind of an interest in the statistics part more. And this is basically econometrics. So that's why I also decided to move more into the data science field and to pursue this master and also collect some work experience in that field.
Yep, sounds great. Thank you. Then we have Goktu, and I had the privilege to have him as a student in the first course that I delivered for this year, for the Master in Big Data and Analytics. And I was very surprised because he's a medical doctor, but suddenly I got a question which was very, very technical. And actually he has a very strong background in software development. So that's something that you have to explain, Goktu.
Hello, everybody. As Raul mentioned, I'm a medical doctor, but I have been learning computer science, mainly web development and mobile app development, for the last 3 years. After receiving a full scholarship, I decided to go for a career change in data science, which I always have been passionate. And also, I think in the future, all services are going to be automated, including medical practices. So I want to be part of this change. This is why I decided to go for a career change.
Great. And actually, you're going to get it for sure. So and you didn't mention it, but you developed an application, or it is a service, an application, or both things, and really interesting.
We have been developing a medical healthy diet app for 1 year. We have 9,000 registered users, and we are providing them AI-powered healthy meal plans. And we are hoping to automate all the processes in the future. We have dietitian friends working for us right now, but we hope to automate processes in the future.
Great. So very, very interesting. So I will actually, I'm going to write a blog post in my blog, and probably it's going to be good if I can share the link to your application and everything that we are talking about, because probably people are going to be interested in this and they can double check. Okay, so without any further ado, we are going to start with the goal of this short video. So let me share my screen. And so I have prepared a couple of slides just to organize everything that we are going to go over today. So basically, as I said before, we are going to build the course environment in the new Apple computers running the Silicon processor, or the M1 processor, whatever it is called. And I'm going to start introducing what this course environment is all about, because actually this is the result of previous efforts at creating an environment that the students can use to put everything that I was teaching, all the theoretical contents, put them into practice. Then Gok2 is going to help us to build this course environment in an Apple M1 computer. And so we are not going to go over the whole process because it's time consuming. So we will show the steps to take in order to build the course environment with the frameworks that you are going to work with. And then Michelle is going to import a course environment with all the components, all the modules that I provide to all my students to go over the different courses. And last but not least, Michelle is going to go over one of the labs that we study in class, and you will see everything working as expected. So hopefully everything works well. If we have the demo effect, yeah, that's live, no problem. We will see how to handle it, but I'm pretty sure that we are going to have a lot of fun. Okay, so let me start with what this OSBDET is all about. So actually, this is a personal effort that I started back in time, because I was spending a lot of time in providing an environment for my students and start playing around with all the frameworks that I was studying. So I decided to create this repo, and basically it's an application which is helping to build this environment. So it had some options that we will see in a moment, and Gok2 is going to drive us through all these options over here. And then, as you can see, there are some predefined modules that we can build. And finally, we will have all these frameworks available for us to start playing around with them and learning, basically. This is not a production environment at all. So if you are relying on this environment to, I don't know, release an application or something like that, you will fail for sure, because this is not optimized and it is not properly sized for any production application. And actually, this is all coming from this blog post. So it was January 2020 when I was trying to bring something else, because at IE we have a cluster, and it's a medium-sized cluster, I would say, or small-sized cluster, but with all the technologies. And the problem is students could use this cluster, but at the end of the course or the master, they didn't have access to it, or it was not that easy. So I thought that it would be very convenient to have a local environment with some of these frameworks. And this was the first attempt. And actually, you go through this blog post, you will see that was huge. And it took me a while to make everything work. So a lot of pages over here. And so the biggest problem of this approach is that every time I wanted to bring something new, or I wanted to update the framework, I had to go over all the steps, and that was time consuming, and that was not going to scale. And that was the motivation to start with this project. And that's pretty much all what I wanted to share before starting with the fun. And so we'll stop sharing, and I will let Gok2 to share his screen, and he's going to show us how to install, let's say, or to deploy OSBDET in a virtual machine that he has created in his Apple M1 computer. And from this point on, he's going to tell us how to execute this builder and how to build a simple module. And then we will jump into what Michelle is going to share with us. Gok2, all over to you.
Thank you, Raul. Let me share my screen.
There you go.
You see two terminals here?
We see two terminals, and we see something called UTM or something like that. Can you tell us a little bit about that?
UTM is built for ARM64 based computers as well. You can it works on top of QEMU, which is an open source virtual machine package.
Yep.
It's very intuitive and easy to use. You can here we have already imported the image file provided.
Okay, and so this image file is basically an Ubuntu installation, right, for ARM64 computers.
Yeah.
Okay, great. So this will be the starting point in order to create our course environment. We have an empty Ubuntu image, but it has to be an image for ARM64 processors. Okay.
and we have two terminals here, and we're going to start executing our codes.
Okay.
First, we're going to connect by SSH to our virtual environment.
Okay, so you're connecting from your computer into the course environment.
Yeah, it's already running. So
Cool.
we should be able to connect. Just make sure that you are running after importing the image.
Okay, and you provide the right password as well?
Yeah, it's crucial. Yeah, we are in the first terminal.
There you go.
Let me, this is the second terminal. So I'm going to give super user privileges to this terminal. And let us check. Yeah, let me reset what we have.
Okay.
Here. So I'm going to clone a fresh folder from Raul's GitHub account.
Okay, you need to install Git because we were uninstalling things, and so we uninstalled too much. No problem.
Yeah, bro.
This is what happens when you're doing a live demo.
Yeah. But
okay, so it
was not a major bug. So
no problem. We will survive. We will survive. No problem. So you're now cloning the repo. Okay, great.
While doing so, let me give admin privileges to the other terminal. We're going to mainly use this terminal to track what's happening in the first one.
Okay. So the cloning process will take a while because there are some big files. So actually, if I don't remember bad, the simulator, Michelle is going to show this IoT simulator. So has some big files, and that's the reason because it takes a while. But probably a couple of minutes or so. Yeah, there you go.
We have cloned the image. Let me move it into the folder. Can you explain more about this branch that you have been working at, Raul, please? This VS21R3.
Yeah, and actually, so when you are working with Git, you can have different branches. So that means you can have your development in different, let's say, stages. So the master branch is the branch that the students are using at the moment. So it has the stable configuration, and everything that I'm adding on top of that is something that I'm working on a different branch. So the current release is S21R2, which is a Spring 21 release 2. Everything else, and actually what I'm doing right now to support these new computers, is going to be part of release 3, but that's not stable at the moment. So I need to polish some of the script and some of the code that is included. And so that's the reason, because you need to switch from the default or master branch into the release 3 branch. Does this make sense?
Yeah, makes sense.
Yeah.
Thank you, Raul.
Great.
With this command, we're going to configure our image for Ubuntu and ARM64. Ubuntu 20, ARM64. Let us check if we could succeed. It looks like so. You see Ubuntu 20 and ARM64. And these are the commands that we can use with the OSBDET builder.
And actually, if you check what I was displaying before, if you access GitHub and you go to this repo, when you have in the documentation, is different to what you are getting here, because I added some new commands or new options. So actually, the setup and the current conf options are completely new, because in the previous one, there was only one architecture supported and one operating system supported, which is Debian 10. And the processor that is supported is the Intel one, which is AMD 64. So basically you have two kind of options: the environment related options, just to understand the modules that are built, the status, the recipes, which is something new that I've added as well, current conf and setup, which is something that we already used. And then there are some operational options, which are the ones that we are going to use right now to build, remove, and cook is a different thing. So that's something that I will cover in a different video, but that's an interesting feature as well that I've added. You can move on.
Let's display the current status of modules then.
Mm-hmm.
You can see that none of the modules are installed. KO means that they are not available. We're going to use this command to install.
Mm-hmm. And now, as you can see here, something is happening, but you don't know what is happening. So yeah, you need to go inside the OSBDET folder. There you go. There you go. And this so because this process is time consuming, sometimes you don't know if there is some progress happening or not. So this second command is very handy, because in this log file, every single step is added to the file. So you will see that right now it is downloading Java 11, I believe. Yeah, it is downloading Java 11, 200 megs. So that means it will take some minutes. And so at least you can be happy that something is happening and behind the scenes. Okay, so the module, what you type after build is the name of the module, right? So every line that you have after the status command is actually a module, and the first element is the module name, right?
Yeah.
Okay.
Should I show an example? No.
No. Let's wait for this module to finish. There you go. So it finished. So you get a done and you don't get any error in the second terminal. That means you're ready to go. I don't see any error there. Yeah.
Let's check the status again, and we're gonna.
There you go. Okay, so this is the process that you have to follow in order to build the course environment, right?
Yeah.
Okay. So at the beginning of every term, what I do is I take an empty image. So I install OSBDET and I start building framework by framework the way Goktuk did it. Okay, so as you can see, the process is very easy. If you don't get any error, of course, when you start getting errors, that's a different story. But if you don't get any error, it is just a matter of installing or cloning the repo and using the OSBDET builder with every single framework. Okay, so for everyone who wants to create their own environment, this is the process. Okay.
I should point out that it's very hard to maintain such an open source project, because these are constantly updated. So Raul's work is totally excellent here.
Thank you. So it is very rewarding when I see students completing the labs in their own computers. So it is very rewarding, because actually the amount of hours that I spend building this artifact, or whatever it is called, pays off. So basically, being able to support my classes, all the theory with this environment, I believe it is rewarding, at least. Okay, Goktuk, thank you very much for your help and for the time, because actually this is a recording that we are doing in, I don't know, 45 minutes or something. But so to get to this point, Goktuk and myself have spent some time on it. So I appreciate your time, and more than happy to make some videos in the future. If when you are very successful with your application or with your new career path and you are famous, so it would be nice that you can give me some time to make another video and show what you are doing, right?
Thank you. Hopefully.
Yeah, for sure. Okay, so let's go with Michelle. Michelle, can you share your screen and drive us through what you are going to do? You are going to import, just to summarize what Michelle is going to do. So let's imagine, and actually this is something Goktuk did a couple of weeks ago. He went framework by framework. He was building full course environment with all the frameworks, and he shared that image with Michelle. So Michelle is going to import this image, and she's going to go over one of the labs that we do in class. So this was a lab that we did in the stream processing and real-time analytics course, if I don't remember bad, right?
Yeah, exactly. So yeah, I'm first going to import the image.
Mm-hmm.
Okay, so I will keep it up running. And yeah, so basically we have each week in Raoul's classes. Can you see my screen?
Yes, we can see it.
So basically each week in our old classes, we have one lab, which we need to complete by ourselves. So the idea is basically to see the course environment like in action, to see how the different modules work within each other and how we can like stream data in real time. So yeah, this was like the last term's class. We also had different labs concerning big data architecture and as well as about Spark. So let me start the lab.
So actually what Michelle is going to share with us, so she's accessing Jupyter notebooks inside the course environment. So if you pay attention to the different modules that are available, there is a module called Jupyter. So when you install Jupyter, you have access to this URL and you can forget the terminal window. So from that point on, you can start working on the different frameworks and implementing the labs, which is very convenient.
Okay, so yeah, first of all, the scenario. So as Raoul already said, I think we have a truck fleet simulator in our course environment. And in this case, like in this specific lab, we are going to consider two types of events, which are one geo and speed events. And so that's basically how it is constructed. Maybe Raoul wants to elaborate a bit more on that sample scenario.
Yes, of course. And there is a funny thing that I believe you don't know. This truck fleet simulator is it's a simulator created by people at Hortonworks. And actually the whole solution engineering team, and so I was part of that team, was using this demo just to showcase the different stream processing technologies within the product. But the marketing team was using the same environment just to pitch what we were doing in this space in the different conferences and summits. So basically what you are going to use here is something that professionals in this big data space were using just to showcase the different technologies. So I believe this is interesting. I don't know if this is interesting for everyone, but at least for me, it's a lot of fun because I'm reusing something that I was using in the past. And I would say Cloudera is still using this simulator just to test the different real-time frameworks that they have in the product. So coming back to the scenario, we have this truck fleet simulator, which is basically an scale application creating some entries in a file. And these entries are representing events. And there are two types of events, as Michelle was saying before. You have the geo events that are representing things that are happening with these trucks. And the most relevant part of these events are the violations. And these violations can be overspeeding, lane departure. And the idea is to analyze all these events and identify something that shouldn't be happening and take actions. Okay, so this is what. So in this scenario, we are going to ingest these events into Kafka because we are building a real-time analytics architecture, and you usually have these kind of elements in this architecture. So we have Kafka where we are going to ingest all these events in a Kafka topic, and then Spark streaming, there's going to be a Spark streaming job consuming these events from the Kafka topic, enriching the events with reference data, which is going to be provided in a CSV file, just to make things simpler. And the enrichment is going to be persisted in a relational database, which is MariaDB. And this is going to be the data serving technology that a business user or someone else can use, or an application or whatever it is, can use for making decisions, displaying visualizations or whatever it is. Yeah.
Thank you. So yeah, let's start with the actual lab. So first we have to make sure that we have all our files. I'm just going to upload them quickly.
Sure. Okay, so can you explain the different files? If you remember, if not, I will help you.
So yeah, first of all, we have the trucksdb SQL file, which basically is just a file with, as probably you all know, SQL commands creating an empty table and configuring like the different types of variables we want to have. Then we have the trucks info, which is basically the CSV file which we use for enriching the data when we're in Spark streaming before actually like sending it to our database MariaDB. Then we have
can you click in the CSV file just to have a look at it? There you go. So it is a very simple one, right? With the 3 columns. Yeah, cool.
So then we have the producer, which basically takes events and sends it to Kafka, right?
Yeah, that's it. So it is taking the events from the simulator and it publishes those events into a Kafka topic. Can you open the code just to see if, yeah, so it is not, obviously this is something that I give my students. They don't have to develop this. But so if you're curious about what this code does, you can open it. It's a very small script, Python script. If you scroll down, you will see that there are 52 lines. So it's a very easy. Obviously, there is no error checking and all those things. So it's something very simple to use. Yeah, thank you.
Okay, and then I think we have the streaming consumer join serving, which actually is a process where we filter for the different events and enrich the data, which like basically building the final data for the batches which we send to MariaDB.
Great.
And the streaming consumer configuration, let me open it. It's
and this is a configuration file for the Spark streaming job. And actually here is where you provide the Spark streaming job, the different elements that are going to be used. So the Kafka topic, you have it there, the group ID, the CSV file that is going to be used, where the relational database is located, the table, sorry, and the credentials. So that's something that the Spark streaming application will use. Good.
Okay. So I guess we have all our files which we have to use. And okay, let's start. So I'm going to open the terminal. And first of all, I'm going to start Kafka. And make sure that it's actually up running and running correctly.
Okay, so that looks good.
Yeah. Second, MariaDB. So our database, which we use in the sample scenario and in the course environment. Same as before, we just check the status and looks good, right?
Yes, looks good.
Okay, this we already had. So these are the different files we just explained. And here we are running the trucksdb SQL. So that was the one where we actually create the table. So here we will just create all the artifacts we will need in the end to store our data in the events data table.
Okay, so it looks like something happened, right?
Yeah. In the next step, we're basically going to see if it worked. So we're going to access MariaDB. And we're going to use our database, which is called trucks. And let's see what kind of tables we have here. stored. So this is our table, which we're going to use during the lab violation. And I'm just going to use the basic describe function to see what is actually in there. And yeah, here we see our different fields, type, and basically what we configured before.
Okay, so that confirms that everything is, so the script that you showed before was properly executed, right?
Exactly, yeah.
Cool.
I'm going to exit. And so now I'm going to start the truck fleet simulator. Again, checking if it works correctly and looks good.
Okay, so basically what you've done up until this point is to initialize the scenario, right? So can you go back to the picture with all the components?
Yeah.
Just to identify everything that we are running. Okay, so the truck fleet simulator is the service that you ran the last, right?
Yeah.
The data loader. Okay, so we have Kafka in the picture, which was another service that you started. Spark streaming is a job. So basically there is no service running. So that's something that you will execute. So nothing has been started at the moment. And finally, MariaDB, which is the service that you started. So you have 3 services up and running, and then you are going to start connecting all these components, right?
Yeah, exactly. So yeah,
Cool.
we just do the pre-configurations now. And so now we're going to start actually the producer. And I just have to define the topic, right? Which I will call truck.
There you go.
And
so basically this Python script is taking the events from the simulator, and it is publishing these events into the Kafka topic called track. And there are some messages there, and these messages are due to an old version of one of the libraries that we are using. And so this is one of the limitations that I found in this ARM64 environment. So in the Intel one, at the moment, we don't get any message like this. So this doesn't mean that it's not working, but something will not work in the future. So deprecation means you are using something that is not new, and at some point it's going to be removed. So hopefully at some point I will handle to find a newer version, and so that message will not happen. Yeah.
Okay. Yeah, I'm going to start a new terminal. And yeah, that's basically what we already described. This is like the process where we actually like enrich the data. So the step in the sample scenario where we had Spark streaming.
Can you show the code in the Jupyter notebook just to see how long this file is? Okay, so these are for each batch function, because basically we are going to put events into a JDBC relational database. So that's not a default sync. Cool. And if you scroll down, so let's see what we have. So basically what you were saying before. So you're creating the Spark session. You're getting some of the configuration parameters that we saw before in the file. There you go. Then you're building the data frame on top of the CSV file. Then another data frame on top of the Kafka topic. There you go. And then you events df. Yeah, just in line 73, you are polishing what you are getting from Kafka, getting the right commands and filtering out by track view event. Okay, cool. And then, yeah, in line 86, by joining the 2 data frames. And what else? And finally, you are starting the job in line 92. So the dot start is starting the Spark streaming job, and it is executing the whole logic. Okay, looks good. Let's see if it works.
Yeah.
Okay, fingers crossed. Successful means we are in the right direction. Okay, so the messages just confirming what we were mentioning before. And batch, I would say, means data is coming in, right?
Yeah, exactly. So yeah, these are the for each batch which are getting executed, and looks like it's working. Yeah, so since we saw that we are successfully receiving our truck fleet data, we're going in the last steps just to check if everything worked. So I'm going to access again our MariaDB database. And again, I'm going to access our database called trucks. And I will just check how our initial data table, which was called violation, is doing. And I'm just going to limit it to 5.
Okay.
And yeah, we can see here our event type, our truck brand, the driver ID and the driver name, which is part of the enriched data. So which the information we're getting from the trucks info CSV. And this is basically the data we just streamed into our database.
Amazing. So it worked.
Yeah.
Basically, what you are doing here is ingesting data in real time and enriching this data with reference data. So something that you have in your data lake or wherever it is. Great, amazing. And so last but not least, what we have to do?
Tear everything down.
There you go, because if not, you could have corrupted data and you don't want that. So you don't have the commands, but I will show you how to do it. So first of all, go through the other tabs where you have the producer and the Spark streaming application, Control-C, and you will stop each process. Okay, so those errors are expected, and this error is expected as well. So now, right now, the Spark streaming job is no longer running, and the Python producer is not producing any event. So it is not publishing anything to Kafka. Okay, so once you have these elements stopped, the next thing we are going to do is to stop the services. So the first service that we are going to stop is the data loader. So you need to type sudo space service space data dash loader space stop. A super secret password. And there you go. So the next one is going to be MariaDB, for instance, sudo service MariaDB stop. And last but not least, Kafka, sudo service Kafka stop. There you go. And in this case, as we are not using VirtualBox, which is bringing a very handy functionality to stop the environment, we need to type on a command, which is sudo halt. Terminated. So that means we can stop everything. And actually, you show the console, you should see a message saying, yeah, system halted. So that means everything is properly stopped, and you can remove all the windows and start doing something else. Okay, so this is something that most of the people forget. And if you don't have any copy of your files, it might happen that your virtual machine is corrupted. And then I start getting a lot of emails saying that my environment didn't work. It's not working. So I've lost everything. So in order to prevent this situation to happen, so you should stop everything properly. Okay. So thank you very much, Michelle. It's been amazing. So that we those technologies in one simple lab. And so I appreciate your time. So I spent some additional time with Michelle. So here, DocTube was very relevant to build the image. And so I spent like a couple of hours or so going through some of the labs to validate that this frame were time. And again, so when you are succeeding at anything that you are doing and you're famous, it would be nice to have you in another video and sharing everything that you are doing. And I'm pretty sure it's going to be amazing. And so probably why not? So you can share what you are doing to other students that are in the same situation as you both are. Okay, so do you want to say something else, or we can finish the video over here?
It has been a fun experience. Thank you as well.
Yeah, I really enjoyed it, and I really appreciate that we got the chance to see like how a data architecture works in real life, because from my past experience also working in a startup, it was very hard to understand, and definitely one of the most complex things we learned in this master. So yeah, that really helped going through the whole environment.
Yeah, and Raul was one of the best professors in the master's program.
Okay, thank you. So I will send you some gifts.
If you don't like your professor, you don't like the topic as well. But if you like your professor,
yeah,
it did. Thank you very much for the good words. And actually, it's a very hard topic. So as Michelle was mentioning, it is complex by nature because there are a lot of moving parts, and so the technology is not that easy. But it's amazing at the same time. So if you're able to love the topic, so you can learn great things, and you can understand how big companies are making the most of these technologies. Okay, guys, thank you very much for your time. And so looking forward to making some other videos about other stuff with you. Okay, take care.
thank you.
take care, bye.